transformations, similarity transformations. And specifically, we're looking at dilations. Now, dilation is going to either be in the form of an enlargement or a reduction. You might think of it as also, and we think about this when we're looking at some of the graphs in algebra, as stretching or compressing when we're talking about transformations and specifically dilations. And so here we're asked to identify a dilation and then find its scale factor of these two objects. Now, if I think about this object, let's pick this color. Object A, which is this smaller triangular shape, although we see that it's kind of cut off there at the y-axis. That would actually be our original object or our pre-image, and then this object designated as B is our image. So we got a pre-image or the original object, and then an image that we're making this comparison to identify, let's see, determine whether the dilation from A to B is an enlargement or a reduction, and then find the scale factor to find the dilation. Well, we're told that it's a dilation, so we don't actually have to prove that. A little bit later on, we're going to prove one to make sure that it's a dilation. Then we have to compare all of the sides and see if they have a common ratio. But here we're just looking, we're told it's a dilation, we're just asked to find whether it's an enlargement or a reduction and then find the scale factor. And of course, just on visual inspection, I can see that it's definitely an enlargement because object B is larger than object A. But in order to find the scale factor, we want to look at some corresponding sides. Now, if let's see what color I might want to put this in. I can see a corresponding sides that might make it easy for me. If I look at this side on the original or the pre-image and this side on the image, then I can use that as a comparison, and we're going to compare object B to object A. So let's see, and since this is lying perfectly on grid lines, I can do this. Let's see, so we're going to say this is an enlargement. And we're going to make a comparison of the length of this side to the length of this side. Let's see, so what have I got coming up here? I got 1, 2, 3, 4, 5. So on this side, by where the B is, I can see that it has a measurement of 5. I don't know what units those are, but that's not matters right now. And here at A, I got 1, 2, 3, 4. So we have a 5 to 4 scale factor of this enlargement. Now I think we should look at one other. I know you're so excited that you can't stand it and you want to see one more, and so do I. All right, we got the same set of instructions. We're identifying a dilation. We're going to find its scale factor. We got A to B, and of course right here is A. This is B. And again, I'm told it's a dilation, so I'm not having to prove every side. So I know that they are similar triangles by the fact that I'm told that it's a dilation. And once again, we're going to, on visual inspection, I can see that B is obviously smaller than A, so it is a reduction. And now all I got to do is find the scale factor. And I got a couple of things I could check since these are both right triangles. I could check this side to that side, or I could check this side to that side. I'm going to do the easiest one. So I'm going to see, okay, here I've got a distance on this grid line on my image of 1. And on my pre-image, my original, I got 1, 2, 3. So I've got a 1/3 reduction, a scale factor of 1/3. Let's check the other side just to make sure it still comes up to a 1/3 just for fun. If I take this leg right here, it went up by 2. And this leg, 1, 2, 3, 4, 5, 6. Well, shazam, 2, 6 also equals 1/3. A little bit, not a complete proof, but a little bit of proof that not only are they similar, they are in fact a dilation or a transformation, and it is a reduction. And you know what? If those two legs have the same scale factor, that means that hypotenuse, which I'd have to manually calculate, is also going to have the same ratio. How about that?